Hello, welcome to session 4 thermal treatment process. Professor Dr. Chen will be on chair. Now I will introduce her to you. Professor Dr. Chen from Tongji University, China. Since 1992, Chen has been working on municipal solid waste incineration and related pollution control when she began her master thesis, and with a similar topic, she finished her PhD dissertation in 1997. From 2001 to 2002, she had been working in ENR Technical University of Denmark, especially on the field of incineration fly ashes disposal. In 2005, she had been promoted to be professor. In 2006, she worked in ENR again on the area of life cycle assessments of waste management and technologies. Presently, her main research fields include MSW recycle via thermochemical methodology such as waste-to-energy, pyrolysis and pyrolysis char utilization, gasification, flue gas cleaning, and fly ash treatment and disposal. She has published more than 130 papers in Chinese and international journals and owned more than 20 patents, including 2 American patents. Professor Dr. Chen, now the floor is yours. You can begin.
Thank you. Thank you for the introduction and welcome everyone in this morning section. It's my honor to give this keynote speech. Thank you all. My presentation is combined pyrolysis gasification oriented to power generation system development. I will talk about from these 5 aspects. First, let me give the introduction of the background. Pyrolysis is an important route for waste-to-energy. Landfill is not a sustainable disposal. All of China will ban municipal solid waste landfill from 2023. And incineration is a major and widely adopted technology, but with a complicated pollution control system, relatively low power generation efficiency and high operation cost. The pyrolysis is a process like this. The waste will be heated to a certain temperature without air supply. So the waste will be decomposed into volatile and char. And when volatile condensed, it will, the pyrolysis oil and the gas can be recycled. It has the advantages like this. It has similar sterilization and volume reduction effect to incineration. And it can also recycle of char, gas, oil instead of only sensible heat like incineration. And it is more clear, it's clear when the 3 products are safely utilized. In the recent 3 years, the paper published in the Journal of Waste Management about the topic of pyrolysis keep increasing. Pyrolysis is also an important technology for distributed municipal solid waste management. For example, it is a good technology to dealing with municipal solid waste in small cities where the installation is not possible and the landfill also not possible. And pyrolysis also can be used to recycle industry solid waste such as plastic and waste tiles for oil production. It's also a good technology to recycle biomass waste for energy and resource recovery like this. But the existing pyrolysis system has its bottleneck. For example, the product quality of the conventional pyrolysis is very poor. The tar is very viscous and difficult to use. And also the char has no ready markets. Therefore, to run an independent pyrolysis plant is not economical and not practical. We have surveyed the municipal solid waste pyrolysis plants in China, and we found that 82% of the products are just incinerated. When all of the products are incinerated, the flue gas should be cleaned, just like the flue gas from incineration plant. Then it has no hygienic superiority. Also, for the very common reactor like this rotary gear, the heat transfer coefficient and the heat transfer surface is very limited, and it also has leakage problem. Therefore, its scale up is very difficult. Actually, the combined pyrolysis and the gasification process had been widely used. Compared to single-stage gasification like this, the combined pyrolysis and gasification process like this is more reliable. But for this system, the operation temperature is high. Therefore, it corresponds to high investment and operation cost. And also, the sensible heat of the syngas is high. Therefore, it decreased heat recovering efficiency. We have developed a new combined pyrolysis gasification system oriented to power generation. In our system, the system consists of a pyrolysis reactor and a reforming reactor. The volatile and the char from the pyrolysis reactor will be introduced into this reforming reactor and to convert the oil into syngas. And then we have a syngas cleaning system to produce high quality syngas for power generation and also for warm system. The temperature in this system is moderate. You can see that the highest temperature just within this range. Therefore, highly refractory material can be avoided for these reactors, so the reactors can be cheaper. The hazardous waste, namely fly ash, is avoided since no installation step is involved in this system. And also the sensible heat of the syngas is less than 5%. Its loss is affordable when we use wet scrubbing in here. And also the calorific value of the syngas is high. We developed the whole system, include this pyrolysis reactor and the reforming reactor, and also the syngas cleaning system, and also the whole system to run more efficiently. We will talk about these three. First, we want to talk about pyrolysis volatile reforming mechanism and its effect. For a normal pyrolysis reactor, the volatile will be evaporated from the solid waste, and the volatile will never contact with the solid again. But we can force the volatile to contact the hot char again, and then the oil in the volatile will be converted into the gas. So when the temperature increases, we can say that the syngas yield increased, and correspondingly, the liquid yield decreased. At the same time, the viscous pyrolysis oil with very dispersed component can be converted into this refined oil with very low viscosity. It's more important that we found that in this process, around 80% of the water vapor in the volatile participate in this oil decomposition reaction, and water vapor converted into the syngas. Therefore, the latent heat of the water vapor recovered. Here, the change of the gas product when the reforming temperature changed. You can see the gas yield of the carbon dioxide, hydrogen, and carbon monoxide, methane all increase with the reforming temperature, but to different extent. And finally, this is the concentration of different gas components. We can say that hydrogen has the highest concentration. This is not good for the syngas utilization because hydrogen is very easily flammable. So it's very difficult for power generation in the gas engine, and also difficult for transportation. So we improve the above system like this. In this system, again, the system consists of a pyrolysis reactor and a reforming reactor, but the liquid oil and oil separated from the condenser is recycled to the system through a burner. And then we have the new syngas like this. And then you can see the hydrogen concentration is very low, but the higher heat volume of the syngas is still very high. When we compare the mass balance and the energy distribution of the three systems, include pyrolysis system and the combined system with oil output, and this system, we can find oil yield is highest, and the energy share in the gas yield is highest, and also the energy share in the gas is very high. And finally, we can have energy recovery rate in gas and oil reach to 75%. This is comparable to other conventional gasification process, but we can obtain much higher quality of the syngas. Then we talk about the reactor development. We must note that pyrolysis is an endothermic process. For the conventional fixed bed or rotary care reactor, the heat is transferred from outside through the wall to the inner side. And because the material inside the reactor is very heterogeneous because it is waste, the heterogeneous waste has a very small content area with the wall, and also the waste has a very lower thermal conductivity. So the heat transferred from the wall to the reactor is very small. Therefore, the capacity of the reactor is very small. Here are the heat transfer coefficient change inside a rotary reactor for different kind of components, waste components. We can say that there is a lowest heat transfer coefficient area for all of the waste. This is within this temperature range. This is just after drying and before the pyrolysis reaction taking place. So actually, it's very difficult to enhance the heat transfer in this area for the conventional reactor. To improve this, we developed a new concept for reactor design. We divided the reactor into two stages. For the first stage, we use this stage to homogenize the heterogeneous waste into uniform particles. In this first stage, we will use the combined direct heating and indirect heating together, and then raise the heat transfer coefficient. The outlet temperature of the material will be within this temperature range. And you can find that this relative stadial models is the index for mechanical strength of this waste material. We can say that when the temperature reach to more than 200 degrees Celsius, only cotton and vapor has mechanical strength, and polymer and plastic knows the same strength. But if we consider about the breaking force of the paper and the cotton, we can find around this temperature, the mechanical strength, namely the breaking force for cotton or paper decreased to zero. So if we raise the temperature of the waste to this temperature range, all of this material can be easily converted into uniform particles. So in the second stage, we will use a very big heat transfer surface reactor like this to finish the pyrolysis reaction of the uniform particles from the first stage. The reactor can be like this. So we have developed large capacity composite reactors with well-organized reaction and enhanced heat transfer. The first stage could be a conventional reactor, but with the improved heat transfer coefficient. And the second stage can be a big, large heat transfer surface reactor. For example, we can use plate heat transfer reactor. its heat transfer surface can be reached 100 square meter per cubic meter. This is 25 times of that of rotary pyrolysis reactor. And this kind of composite reactor has been selected to be the key technology in Shanghai Green Technology Bank. And we also have developed many reforming reactor for different kind of materials. And these are some examples of the composite pyrolysis reactors system we have developed. These are movable reactors, and these are big one. We have a very small, fast moving for this. Yeah, this is a very this is our pilot testing system, and after this is the composite reactor. It's a very small but a big capacity. And then we have the cyclone for Syngas scrubbing system. This is the Syngas scrubber, and this is the PLC control system, and this is the tower. Also, we have DCS system. And this is the condenser to separate oil and gas. And this is the gas tank. And this is the furnace for the Syngas to supply the heat for the whole system. Yes, you can see the gas burning here. All the gas is produced for our own system. Now we talk about the Syngas purification. We have developed a system like this for removal of tar, particulates, and other contaminants from the Syngas. It's include cooling system. The cooling system include condenser and the water cooling water recycling system, and the oil scrubber, and the alkaline solution washing tower. And here is the performance of the condenser. Just inside the condenser, you can see about half of the particulates and more than 90% of the tar can be removed. And this is the performance of the oil scrubber. When we use the soybean oil as the absorption agent for the tar and the particulates, you can see 100% of the particulate can be removed. This is before scrubbing, and after, no particle at all. And most of the tar can be removed. But for this sulfurate hydrogen and ammonia and VOC, oil scrubber has no effect. Then we use a sodium carbonate solution washing towel for this. And by choose proper parameters, the sulfurate hydrogen can be totally controlled. And this is the final emission from this sodium carbonate washing tower. You can see all of these contaminants decreased to a very lower concentration. We also try to use the pyrolysis oil from our own system to replace the soybean oil. We compare this reformed pyrolysis oil with the soybean oil, and we can see that when the absorption temperature increased, the absorption efficiency decreased, obviously, but soybean oil changed very little. So the reformed pyrolysis oil is not so good as soybean oil. We also check the reason, and we found that the reformed oil is very easily to be carried by the Syngas. Here are weight loads to represent how much amount of reformed oil can be carried by the flue gas. And the more means the more amount of oil can be carried by the flue gas, by the gas or by the Syngas. You can see higher temperature and higher flow rate will take more oil from the absorber. So we improved this system by just this distillation system. When we get the reformed oil, we use a distiller to separate some night compounds at the 98 degrees Celsius. Then we use this residual oil as an absorbent for syngas absorption in this system. And finally, you can see this reformed pyrolysis oil after distillation behave the same as vegetable oil. This is for removal of the tar, and here are for removal of the particulates. The two oil behave the same. And also we have checked the exit from the final exit to see the light compounds. These also are light compounds that are very easily carried by the syngas. And we found that if we use only the reformed oil as an absorbent, and these light compounds steer in the syngas. But if we use vegetable oil and we use the reformed oil after distillation, these two oil behave the same. No tar, these light compounds can be seen from the syngas. Finally, all of the contamination in the syngas can be reached to a very lower concentration, and the quality of syngas can meet the requirements of the inner combustion engine after purification. Finally, we want to talk about inner combustion engine for syngas from the municipal solid waste. We can obtain very high quality syngas. The heat value is much higher than other gasification process, and we also meet the requirements of these pollutants for entering the combustion gas engine. But for a normal combustion engine, all of these gas, the methane sparked with hydrogen or pure hydrogen or carbon monoxide has been widely investigated. But our gas is not investigated, or we need investigation for very small inner gasification power generation. Some investigations show that for inner combustion gas engine, the spark here, maybe we must change the spark plug area. For example, we may need a pre-combustion room here to some easily flammable gas, for example, hydrogen. But this investigation is still ongoing. We need much effort for this. So the conclusion, we have developed a pyrolysis reforming process for municipal solid waste gasification, and high quality syngas is obtained. And we also have developed a composite reactor with large capacity, and we have developed synthetic gas cleaning system, and the syngas can be cleaned to meet the requirements for a gas engine. And the gas engine should be investigated to adapt to the gas of a mixture of carbon dioxide, hydrogen, methane, and carbon monoxide. So thank you, and your questions are welcome. So any question for me? I wonder the voice is okay. So any question? Okay, if no question, we will move to the next speaker. Can you tell about economic value? Okay, Somebody asked me about economical evaluation. Just from now of this process, we have compared this process with the incineration, and at least we think this the operation cost is cheaper than incineration system. And for per ton of waste disposal, for our system, the operation cost can be about 61 RMB cheaper than the incineration system, because we have no fly ash disposal, and also the Syngas cropping system is much smaller and very simple than the flue gas cropping system in the incineration plant. To develop countries for okay. I think this kind of system is because the capacity is still small than incineration plants. The maximum, I think, can be maybe up to 200 tons per day. So I think it is suitable for developing countries, and also for distributed municipal solid waste disposal, even in big cities. And scale up of the pyrolysis, I think, is now only 15 tons per day is available. And for biomass, maybe even bigger is available.
Can I ask you something, Professor Ghoshia?
Yes.
Yeah, do you have any pyrolysis plant using municipal solid waste in China, or do you have any plan?
Yes. Formerly, we ourselves set up municipal solid waste pyrolysis plant in Qingdao, just by ourselves. After run for 2 years, that plant closed because they want to replace with a very big incineration plant. And now, in many small countryside, in many small cities in countryside, I think there are maybe 40 small pyrolysis plants are in operating. But for this plant, most of the products are just incinerated just after the pyrolysis reactor. And for the system like this is only used for plastic waste pyrolysis. There are 3 lines are in operation. Thank you. The moisture limitation for the municipal solid waste, I think for this system is not so strict, but it's just like incineration, or like very similar to incineration and gasification. The moisture is better to be lower than 35%, or is better to be less than 30%. Is better, because if the moisture is high, then you need more weight to evaporate water. Okay. If no question, we will move to next speaker.能看到我的那个，看到吗？这个看的是那个 doctor， 那个 是的是吧？ Okay, the next speaker is I'm so sorry, it's difficult for me to pronounce the name. The Arslan. He works as a R&D manager in Aero Environment Technologies. Mr. Arslan received his bachelor and master degree in environment engineering in 2009 at the Berlin Technology University. He has worked in private sector as R&D and environment engineer and as a research assistant at Leipzig Technology University. He has many national, international patents and academic works in water, wastewater treatment and membrane technologies. He works also as a lead audium by K1 Mail and for a long time and in the field of management system for some international standards. So welcome, Sinan Arslan.
Yes. Can you hear me, Ms. Chen? Can you hear me?
Yes, I can hear you.
Thank you so much for the introduction. That was a very technical presentation. That was a very nice presentation. My presentation will be a little bit general in comparison with your presentation. It will be about. Yes.
I'm wondering, can you share your screen?
Yes, I am doing now. Okay.
Yeah.
Can you see it?
Yes.
Okay, I can start. So, the presentation will be about energy and raw material recovery from end-of-life tires with pyrolysis method in Turkey. It will be a general presentation. The technical details will be not mentioned very in detail. I am Diploma Engineer Serkan Arslan. I am the R&D manager of the company. So I would like to talk about the Siyah Kalem Group. The Siyah Kalem construction company, it is one of the most prestigious construction companies in Turkey. And ERA Environmental Technologies belongs 100% to Siyah Kalem. And also the Sekai, another environmental company, belongs 100% to ERA. The group is founded in 1977 and has delivered numerous international level contracts in time and budget. It desired quality in many sectors. The projects from design level to commissioning stage have been executed in Turkey and abroad, including Pakistan, Somalia, Djibouti, and other countries. And currently, Siyah Kalem is focusing to diversity its field of activities and investments in emerging sectors such as energy and environmental technologies through its affiliate company, ERA Environmental Technologies. The value of completed ongoing projects is over $1.65 billion for Siyah Kalem, and its sectors can be sorted under real estate development, energy, environmental investment, capital investment, and of course, the construction projects. Erzincan Biomass Power Plant has 7 megawatt license and 12 megawatt installed capacity. It is the first and only power plant that produced electricity from end-of-life tires in the world. We have also a fully integrated solid waste management plant with a capacity of 14 megawatt electricity production from biogas and landfill gas. ERA Environmental Technologies is one of the group companies, is the leading service provider in medical waste treatment sector in Turkey, and it has established for the Istanbul metropolitan municipality the biggest medical waste sterilization plant with fully automated system. Siyah Kalem Group has been involved in the environment sector through its affiliate company, ERA Environmental Technologies Incorporation, acquired in 2007 to develop and execute projects in environmental and infrastructure sectors. ERA Environmental Technologies has been the pioneer in Turkish market, particularly in waste management and waste to energy technologies. ERA is the leading service provider in medical waste treatment sector in Turkey, operating in various major cities, including Bursa, Sakarya, Kütahya, Kastamonu, and Sivas, and the world's largest and fully automated medical waste sterilization facility was established by ERA for Metropolitan Municipality of Istanbul. ERA has been exploring options and focusing on renewable energy projects in recent years. And ERA has developed its own know-how of a continuous pyrolysis process to produce energy from waste to tires. As mentioned before, the installed capacity of 12 megawatt electricity production capacity in Erzincan plant, and Sekay has 14 megawatt capacity, including the biogas and landfill gas electricity production. ERA has made a strategic decision to evaluate opportunities to further invest in pyrolysis power plant projects, manure biogas plants, landfill projects, medical waste collection, and transportation strategic regions of Turkey and abroad. ERA fields of activities, waste management, medical waste, collecting of medical waste treatment, waste collection, waste transporting, landfill gas operation, composting, vermicomposting, organic fertilizer, recycling, recovery, RDF, SRF production, organic waste to biogas, green cut to biogas, manure to biogas, sewage sludge composting, and digestate composting. So we have in operate, except the established and delivered plants. In operation plants, we have in Bursa, Sakarya, Kütahya, Kastamonu, Sivas, 5 medical waste plants. In Sakarya, we have fully integrated waste management project. And in Erzincan, we have a biomass power plant from end-of-life tire. And it is included as biomass in Turkey according to related regulations. So this is the overview of the plant. We have an RD center here, official RD center approved by the ministry. We have a tire collection area, then comes the tires to granulation unit. After it is granulated, it goes into the pyrolysis unit. It is self-designed, rotary clean, continuous operated reactors. 4 reactors with each capacity of 15 tons per day granulate processing. Then after this, we have separation towers and condensers. Then we have oil processing units, such as filtration, such as storage to remove the water from the oil. Then after we do the analysis in our laboratory included in our RD center, if the oil quality is on the level that we can send it to the generator, then we produce your electricity from the pyrolysis oil under the regulation of EWMS. This is a mechanism that supports the renewable energy production, and we can sell it to almost 3 times more than normal price. You see here the total field is 83,000 square meter. The tire preparations, the granulation unit is 2,000 square meter. The pyrolysis unit is 2,600 square meter, and the electricity production area is 1,200 square meter. We have established our official R&D center in 9th April 2019. It is the only R&D center in the field of chemistry in Erzincan. We have closed TÜBİTAK research and development project successfully. One TÜBİTAK 1501 project is continue already. And we have also 5 internal projects. We have 10 national publications. 1 is now submitted. 3 published international publications. 3 university cooperation. 1 industry cooperation. Pyrolytic oil and carbon black laboratory. And we have an innovative project, Teknohamle, with 10 million TL RD, Turkish lira RD budget. It is about the supercritical water oxidation. So if we summarize our innovation potential, first medical waste sterilization plant in Turkey, first electricity production plant from end-of-life tire in the world, full integrated waste management plant, self-designed continuous tire pyrolysis reactor and line, and the only R&D center in the field of chemistry in Erzincan. So we have 8 patent applications. 2 of them is about the pyrolysis line and reactor. It's continuous operated. Others are about the products that we produce from pyrolysis of end-of-life tire. It's in liquid form and solid form, carbon black, and some of oil parts. We have also trademark registries. And we have all 7 registries already done. If we summarize our process, we collect the scrap tires from Laster. Laster is the only authorized institution in Turkey which can collect scrap tires. And that's a big question in Turkey. We have to pay for the tire. We dispose, we treat the tires, we make it to energy and raw material, but we have to pay for it according to our regulations. Then the tires are shredded into small parts. This is the PSD, particle size distribution of granules is very important. Smaller particles means more surface area and more efficient pyrolysis process. And the thick tires from the OTRs is removed from the tires and can be sold. Also, we have thin tires from car tires and truck tires, and this thin tires is removed before inlet of the pyrolysis reactor. With magnet separators, but it is a little bit contaminated with textiles. The textiles should be removed to make it that we can sell this tire because the textile is a contamination unit part of the tire. The pyrolysis process, as you know, is decomposing organic chemical bonds in oxygen-free environment with heat effect. We remove the oxygen with nitrogen to make the available oxygen-free environment. Then, as you know, we heat the reactor, and because of the thermal decomposing, the organic part of the tires goes into the gas phase. Then it is the light oil and heavy oil separated in the separation towers. Then they are condensed and turned into the pyrolysis oil, tire pyrolysis oil. And in our system, we separated them first, but then we mix them together again. Then after the cleaning processes of pyrolysis oil, we send it to generator to electricity production. The water content of the oil is very, very important. If the water content is over 10, over 1000 ppm, we can have some problems with the generator parts. Then also we have carbon black, the char of the pyrolysis process, and this carbon black is sold to the rubber and tire producers as binding material. So I can pass this slide fast because I have already talked about it. You see here some pictures from our plant. Here are the here are the wires, steel wires that we remove from the OTRs.
Sorry, please remind in the time. Sorry. Yeah, 2 minutes.
Sorry, I didn't understand. Again, please.
I mean, only 1 minute.
Well, okay.
Yeah.
Okay. Then products and application fields. From the old granulate we can achieve for 43 and 47% of pyrolysis oil is produce electricity by fuel oil generators. And we have syngas that we cannot condense to pyrolyze to oil, that we use it to heat the reactor again. We have carbon black, and also as I said, we have syngas. You see here atmospheric distillation result of our oil. It's benzene. It includes benzene, kerosene, diesel. The cracking point is 262 after this, and by this cracking point we get the 96% of the oil. You see here a classical analysis of our pyrolysis oil. Here is a very important parameter is the water content to burn it in the generators. The carbon black is one of the most important output of the plant. We get it as powder, and we make it more smaller to get a smaller particle size distribution, and we sell it to tire industry, conveyor, belt making, rubber industry, paint industry, auto parts industry, and bitumen addition. And we have also patent application for earthing resistant reducer. The carbon black is a very important material. Also in Turkey, we import nearly $200 million carbon black, virgin carbon black from other companies. You see here some pressed rubber components produced with ERA CBR. And for example, if I give you an example, Volvo Cars has fitted in 2 years 40 million components made with 100% CBR. And our aim is also that the all CBR that we use can be used in production in Turkey, in tire production, in rubber production. So we have another research study. We tried our CBR carbon black in bitumen, modified bitumen production, and we see that ERA CBR can be used as modification addition for the bitumen addition, and that will decrease the cost of modified bitumen production and SPS import, which is used in bitumen production. So currently our facility production capacity is 25 tons per day. If we can make it available in production, approximately 33,000 tons of carbon dioxide emission reduced per year, and we prevent the consumption of approximately 18 tons of petroleum-derived oils annually. And if we evaluate the economical potential of end-of-life tire in Turkey, 350,000 tons of end-of-life tires generated in Turkey, and 180 and 200 tons of can be collected by Lastar for recycling and recovering. With the recovery of, if all the potential can be used, then 380,000 tons of LAT pyrolysis, then we get from this almost 45,000 tons scrap tire, which has the value of nearly 5 million euro per year, and carbon black is 152,000 tons, and the value is almost 45 million euro per year, and the electricity production capacity is 800,000 megawatt electricity production capacity per year. Okay, thank you for your attention. Thank you so much.
Okay.
Any question?
Some question is available in the chat area, so you can answer.
Yes.
So people ask the carbon black quality.
Yes, that's a very good question. The carbon black quality is lower than virgin carbon black. And we have a motto as recovered carbon black is not a carbon black, it's not carbon black. And also the ash content is by virgin carbon black under 1%. And we have also in Europe, in all around the world, it is about 15 and 20%. In Europe, in 22% ash content. And also, because your pyrolysis process is operated with heat, the originality of carbon black can be also decreased. Because of them, because of all these reasons, the rubber producer, the tire producer, can use it only with combining with its virgin carbon black. What important is you have to have a standard production, and you have to give all the producer in standard quality recovered carbon black. Then they can know that if they use 10% from, for example, ERA CBR, then if they can use 10% ERA CBR and 90% from virgin carbon black, the quality of their product is not affected negatively. That is the point by the recovered carbon black.
Okay, did you say the generation, power generation per day? How much?
For carbon black?
No. It's both. With how much electricity can you generate approximately per day?
So we have now the capacity of 6. We produce now 8 megawatt. It depends on the operation conditions, weather. While in hot weathers, it is important for the condenser capacity. It can change, but we have to make them stable at 6 megawatt per day.
Okay. I have one question: that how you dispose the water from the oil?
Yes, we store it in tanks, and then we remove it from the bottom of the tank. Then it goes to another tank. We have this stage by stage tanks that we can remove the water from the bottom of the tanks.
But you don't treat the water before discharge.
Yes, Yes, we give them to licensed institutions that regularly treat this water, oil water.
Okay.
Thank you.
No question? So thank you. We will move to next speakers. Thank you. Oh, so the next speaker is Beşirli. I wonder Beşirli is here.
Hi.
Hi, yeah, because I have don't have your with me. So could you introduce yourself?
Can I start?
Yes, you can introduce yourself because I don't have your introduction.
Sorry. Okay, I am start. Hello, dear participants. I am master student in Gebze Technical University. My supervisor is Professor Murat Doğru. Today, I will present you my study on biomass gasification cleanup systems. Firstly, I would like to explain what is gasification. Gasification is the process of converting carbon-based feedstock into gas product with partial air and high temperature. After gasification process, syngas is produced as the main product. Syngas is an important product of gasification, which consists of mixture hydrogen and carbon monoxide, and can be converted into energy raw material, fuel, and chemical materials with different process and different carbon monoxide and hydrogen ratio. Some pollutants also are produced in the gasification process. The major pollutants are particulate matter and tar, and also sulfur compounds. Ammonia and chlorine were produced. Before the syngas can be used, these pollutants must be removed. This research is aimed to gasify the biomass in a fixed bed gasifier, to purify the pollutants in the syngas produced in a compact and integrated hot gas cleaning system, and to produce the syngas in a quality that can be used in electricity generation. Now I am going to talk about our pilot-scale gasification reactor. This reactor is an updraft reactor, and it has capacity 150 kilogram per hour. Shown in figure 1 is feedstock feeding system. Figure 2 is PLC control panel. We can control the whole system, and data are recorded periodically. Shown in figure 2 is grid system, and
Sorry, I can't see your screen is moved. Did you move your screen? I can't see any movement.
yes, don't you see?
No movement.
Now, wait a minute.
Oh yeah.
You can see?
Yes.
Okay. This figure is feedstock feeding system. Figure 2 is PLC panel. We can control the whole system, and data are recorded periodically. Shown in figure 3 is grid system, as you see. And figure 4 is flue and the connection of the thermocouple. And this is wood chip that were used as feedstock. This graphic is thermogravimetric analysis result of wood chip. According to the analysis result, 25% loss was observed at 300 centigrade degree. 80% loss was observed 500 degree, and it's seen that then the sample remained only 8% by mass at 900 degrees. The gravimetric analysis shows that the wood chips can be gathered at high temperature. In this picture, you can see the design of intensive and integrated filter system. The cleaning system is covered isolation material to keep the temperature, then wrapped with a resistance to heat the gas 900 degrees Celsius. In the innermost part, a replaceable filter assembly was placed and catalysts were filled in the filter. In addition, a thermocouple and a control panel are connected to system to control the temperature level of resistance. This system was placed at the end of the reactor. Stainless steel filters were used to remove particulate matter, and nickel-based catalyst was preferred for tar removal. The figure on the left shows the result of high-resolution scanning electron microscopy analysis for nickel catalyst, and the figure on the right shows the result of X-ray diffraction analysis for nickel-based catalyst. The XRD result shows that nickel-based catalyst is composed bunsenite, silicium, and hercinite. To determine the pollutant load of the gasifier reactor, firstly the module 1, module 2, module 3, and module 3, all series were placed one after the other as shown in figure. As a second step, an integrated filter system was implemented between module 1 and module 2 in order to investigate effect and efficiency of stainless steel filter and catalyst in Syngas cleaning. Rotameter and pump are placed at the end of the impinger bottles for the adjustments and control of the gas flow rate. The reactor was operated with a feed rate 100 kg per hour. Sampling was started after Syngas produced, and sampling time was nearly half an hour. A fuel filter was placed in the filter holder shown in figure 2, this place. And then the filter was extracted with isopropanol by Soxhlet extraction in the laboratory. Those particulate matter and tar were separated, and the amount of particulate matter in the gas was calculated. And then 100 milliliter sample was taken from the total tar sample in isopropanol from the impinger bottles, connection pipes, and Soxhlet extraction, and placed in a rotary evaporator. The amount of tar was calculated by separating isopropanol and tar from each other. In order to see the experiment step in detail, you can check the tar protocol. In this table, the operation condition and result of particulate matter and tar concentration are given, and also optimum level of particulate matter and tar concentration are given in the second table. As you can see, the determined amount of tar and particulate matter concentration in the syngas is higher than optimum level in gas application. We have started this experiment recently, and this system is not optimized yet. We continue to study on it and try to figure out the reason of this high tar and particulate matter concentration. This work was funded with contribution of TÜBİTAK. We are grateful to the Kastamonu Entegre Ağaç Sanayi ve Ticaret anonim şirketi grup for providing the raw material, and Disan group for feedstock feeding conveyor system, and Gebze Technical University for our laboratory studies. Thank you for attention. Do you have any question?
So, any question for her?
I can't chat.
So I have one question for you. Your method can remove tar and particulates at the same time?
Sorry, you can ask again?
Yeah, I wonder whether your method can remove tar and particulates at the same time.
Yes, it's the same time.
And they have no just conflict. Any conflict between the two pollutants?
We designed as shown. Sorry, this one. We are putting the filter and catalyst. We aim to remove both of them.
Yeah, I understand that a nickel-based catalyst can just correct tar. I'm just wondering whether the particulates has some bad effect on the nickel catalyst.
I don't understand. Sorry. Can you translate? Someone can translate?
I mean, whether the particulates, the dust, has any bad effect on the nickel-based catalyst.
Yes, we will analyze in SEM and inside the filter and catalyst, but we are not study yet.
Okay. Any question? Yeah, if no question, we will move to next speaker.
Thank you.
Dr. Feng is an associate professor in Tongji University. Actually, he's my colleague. He will introduce the effect of hydrothermal treatment on the gasification performance of calcium oxide conditioned sewage sludge. So please, Dr. Feng.
So good morning, everyone. It's my honor to give this speech here. And the title of my speech is The Effect of Hydrothermal Treatment on the Gasification Performance of Calcium Oxide Conditioned Sewage Sludge. First, I will talk about the background. With the faster development of China these days, the sewage output is increasing rapidly from 2011 to 2018, and the sewage treatment capacity has reached almost 60 million cubic meters per year, and also the sewage sludge, which is the solid production of the sewage treatment process, has also been over 6 million per cubic per year, and its growth rate is also 10% every year. And for the sludge treatment in China these days, we just use the landfill incineration, land use, and building materials. Among them, the incineration is very attractive disposal process in big cities, especially in eastern China, since it could eliminate the organic compounds in sewage sludge, and it will compared with the incineration, there are some promising disposal methods such as the sludge gasification and the sludge pyrolysis. For sludge gasification, it's also a thermal process which could destroy the hazardous organic compounds. Moreover, it could transform the carbon and hydrogen elements into the combustible gas in reducing atmosphere, and it could just turn the organic compounds in a high quality products compared with the incineration process. But still, it has some disadvantages, just like the tar formation, which will cause the erosion of the next pipes. And also the gas quality of the sludge gasification is also need to be improved. And before the gasification process and the incineration process, the sludge moisture is a very big problem. It could be divided into 4 parts, just in this slide, and the water content in the sludge from the sewage disposal plant is often around 80%, 80%, and the reduction of the 80% moisture to 60% will just reduce the half of the volume of the total sludge, and the water reduction itself is 62.5%. It is a very high value here. And for the incineration process, we often use the heat drying process, and its energy cost is very high. And sometimes we just use the hydrothermal process in a closed reactor, just raise the temperature, and most of the water is in the liquid state. So the cells in the sludge could be distracted and the energy could be saved. So after that, if we use the mechanical process, it is very easy for us to reduce the water content to around 50%. And also the hydrothermal treatment has a promotion effect on the gasification process. And in our previous study, we'll find that the tar content in the gaseous products will be reduced, and also the hydrogen content will be raised. And also, some of the pollutants, such as the ammonia and the hydrogen chloride, could be reduced by the hydrothermal process. And sometimes we just use the calcium oxide as a conditioner for the sewage sludge. First of all, it will reduce the water content since it's an inert material, and the heat could be released from the adding of the calcium oxide. And also, it will enhance the mechanical drying performance because it could reduce the viscosity of the sludge. And another reason is the sanitation reason, because it could kill the bacteria and the pathogens. And also, for the gasification process, the calcium oxide is a very good catalyst, and it is proven in the gasification of the biomass. So the motivation of this research is to examine the hydrothermal treatment on the calcium conditioned sewage sludge. And this is the material from the sewage sludge from a sewage treatment plant in Shanghai. And it's after the mechanical concentration and as a centrifugal dehydration. The moisture content is around 80%. And its lower heating value is 12.99 megajoule per kilogram. And this is the hydrothermal device here. And we just use the two temperatures, the 200 centigrade and the 260 centigrade. And the hydrothermal time is half an hour. And the calcium oxide addition is 10% dry base. And this is the gasification device. We just use 5 materials, the raw sludge and the hydrocharge of the conditioned sludge. And also we just added the calcium oxide in the dry state. So we just use the DM here. And we also added the calcium oxide to the wet sludge. And then we dry it to remove the water. So it's named as CS. And the mass ratio, just to improve the gasification process, to just raise the hydrogen content and reduce the tar, we just use the steam as the agent. And the steam to free rock ratio is 2.4 to 1. And the temperature used here is 900 centigrade. So these are the products from the hydrothermal process. And from the industrial analysis and the element analysis, we could find that the volatiles will be just reduced during the hydrothermal process, since the heating of the material here. And also we just use the hydrothermal char without the calcium oxide addition. And we couldn't find that the fixed carbon of the hydrochar will be raised, since the aromatization process during hydrothermal treatment. But for the hydrochar with the calcium oxide addition, we could find that fixed carbon is reduced. This is because of the test problems, since during the pyrolysis process, some of the carbon oxide and some of the steam released will be reacted with the fixed carbons. So, and also the heat values will be reduced after the hydrothermal treatment, since the addition of the calcium oxide, which will not contribute to the organic compounds in the sludge. And then is the FTIR of the materials. We could find that the peak of hydroxide and the nitrogen hydrogen groups will be reduced with the hydrothermal process. This is because of the dehydration and also the destruction of the proteins during the hydrothermal process. And then these two peaks are the amides. It could also be found that the amides will be reduced by the hydrothermal treatment. And this is the peak of the CH bond in the aromatic rings. Now we will find that when we raise the hydrothermal temperature, the aromatic compounds will be increased, so that the peak will be increased correspondingly. And these are the BET results of the hydrochars. And we could find that when we add the calcium oxide in dry condition, the BET will be increased. This is because of the pore structure of the calcium oxide agent. And for the CS, for the in the conditioned state, the surface area will be reduced. That is because the combination of the sludge matrix and the calcium oxide. And after the hydrothermal treatment, since the release of the volatiles, the pore structures will be developed, so the surface area will be raised. But when we raise the hydrothermal temperature, we'll find that the surface area will be reduced. This is because of the better connection of the sludge matrix and the calcium oxide with the higher hydrothermal temperature. And this is the yield of the different gas components. We will find that the hydrogen is took the main proportion of the gaseous products, and then the highest hydrogen yield was achieved for the CHT 200. And after adding the calcium oxide in the dry condition, we'll find the hydrogen will be raised because of the heat released from the carbon oxide absorption, and also the carbon dioxide decreased by the absorption of the reaction 2 will also promote the reaction 3, 4, and 6. Just from the view of the equilibrium of the chemical reactions, it will just promote the production of the hydrogen. And when we add the calcium oxide in the wet condition, just for the CS, it has a higher hydrogen content. This is because the higher adsorption ability since the better mixing. And after the hydrothermal treatment, the hydrogen per yield will be even increased. This is because the higher charge surface area. From the view of the gasification, we have the volatile gasification with the steam and the gasification of the fixed carbon. And in the sludge, the fixed carbon is took a very small proportion. It's only 5%, but the volatile content is as high as 40%. So it's very important for the volatile gasification on the surface. And we found that in the BET result, the surface area for the CHT is much higher compared with the raw materials. So it's because of the in situ reforming that increased the hydrogen content for the CHT. And for the CHT at 260 centigrade, also we found that the surface area was reduced, which is not helpful for the decomposition of the tars and for the other gasification process which could produce the hydrogen. And for carbon dioxide, we found that for the dried mixed samples, the carbon dioxide will be reduced. It is because that the calcium oxide addition, which will cause the less total carbon dioxide produced. But for the CS, the conditioned sludge, the carbon dioxide will be increased. This could be also explained from the view of the chemical equilibrium. The adding of the calcium oxide just promoted the reaction of 3, 4, and 6, which just increased the carbon dioxide production. For the hydrothermal charts, we could find that the carbon dioxide just continuously decreased with the hydrothermal depths. This is because that some of the carbon dioxide just released during the hydrothermal treatment, so it will reduce the carbon dioxide release during the gasification process. And for the other compounds such as the carbon monoxide and the hydrocarbons, they have the same tendency. They are continuously increased with the pretreatment depths. Now for the gas yield, we could find that the gas yield has the opposite tendency. Gas yield has the same tendency with the hydrogen oxide. This is also could be explained as the same way of the hydrogen production. And also, when we check the retention rate of the volatile matter, we could find that the hydrogen with the calcium oxide condition, the volatile matter retention will be largely increased by the addition of the calcium oxide. This is because the just the retention of some of the fatty acids by the calcium oxide. And also, if we raise the hydrothermal temperature, the retention rate will be reduced. This is also the reason for the gas yield reduction. And for the high heating value, it has the opposite tendency of the carbon dioxide, because we know that carbon dioxide will not be helpful for the heating value of the gaseous compounds. And for the tar yield, we could find that by the calcium oxide addition, the tar content will be decreased from 4.5%. And for the CHT 260, it is reduced to 1.75%. So it is largely reduced by the calcium oxide addition and also by the hydrothermal treatment. And we could find that by the hydrothermal treatment, the pH will be increased in tar. This is corresponding to our findings in our previous studies. This is because of the hydrothermal treatment will increase the polymerization of the hydrocarbons and also for the aromatics in the sewage sludge. So these are the conclusions. Firstly, the conditioning promoted the catalytic effect of calcium oxide compared with the dry mixing, since the better distribution of the addition. And since the developed pore structure and the carbon dioxide releasing during the treatment, the CHT has a higher hydrogen yield and a lower carbon dioxide yield than CS. And the hydrothermal treatment also inhibited the tar formation since the loss of the volatile during the treatment. The hydrothermal temperature at 200 centigrade is more suitable compared with the higher temperature, since the higher surface area of the hydrogel, which is helpful for the reforming of the tars on its surface. So this is the ending of my presentation. Thank you, and welcome for the questions.
Okay, thank you for Dr. Feng. Do you have any question for him? No question? Okay. One question, just one question. So what's the most suitable amount of calcium oxide that should be added to the sludge hydrothermal process?
I think just in this research, we did not change the ratio of the calcium oxide, but in some other studies, we just adjust the calcium oxide addition. I think it will depend on the economic reasons, because when we add the calcium oxide into the sludge, the heating value will be reduced. And above all, we found that 10% will be better than 20%, since I think the gas yield, it's just a compromise of the gas yield and the heating value of the gas yield. So I think 10% is the better according to our research here. Thank you.
Okay, thank you, Dr. Feng. If no question, we will move to next speaker. So, Dr. Ge, he's a PhD student in Tongji University. He is doing some modeling of sewage sludge pyrolysis in a vertical furning pyrolysis reactor. So please, Dr. Ge.
Hello everyone, my name is Shaoheng Ge. I'm from Chongji University. The topic of today's speech is CFD-DM, modeling of sewage sludge flow in a vertical falling pyrolysis reactor. The report includes the following 5 parts. Firstly, look at the background. In China, the annual output of sludge in 2020 is expected to reach 60 million tons. And the sludge disposal methods include landfill, composting, natural drying, and incineration. In recent years, pyrolysis technology has received more and more attention with outstanding advantages of reduction, harmlessness, recycling, and cleanliness. And the choice of pyrolyzer plays an important role in the pyrolysis technology. The reported waste pyrolyzer include a fixed bed reactor, rotary kiln, fluidized reactor, and tube reactor. Of all the reactor, they have more or less problems such as low heat transfer efficiency, difficulty to seal, and high power consumption. Considering the characteristic of the sludge, we propose a new type of pyrolyzer, namely a vertical falling reactor, where the sludge falls by itself under the action of gravity, so it consumes less power and it is very easy to seal, and the heat transfer surface can be arranged flexible, and to improve the heat transfer performance. High temperature flue gas is induced from the top of the reactor to heat the sewage sludge directly, and the high temperature flue gas can promote the tap to crack. Besides, the vapor has an important influence on the char. Well, learning about the heat transfer characteristic is very necessary for the design of the reactor, and numerical simulation is an effective method. And the pyrolysis process of sludge in the vertical falling reactor is a typical dense solid reaction system. There are two main numerical simulation methods for dense gas solid flow, Euler and Euler-Lagrange method. The CFD-EM method used in this research is a typical method of Euler-Lagrange method. Based on the CFD-EM method, the Euler method is used in the gas phase, and the DEM, which is short for discrete element method, is adopted in the particle phase. In this model, several assumptions are made. For the dense gas solid flow, the flow type of the gas phase is usually assumed to be laminar. The conservation equation of mass and momentum can be written as follows. And the solid phase is solved by the DM method. And the drag model used in this research is Organ and Wenyu. As for the heat transfer models, they normally include three parts: convection, conduction, and radiation. And in this research, the radiation is neglected. And in the particle deforming model, it is assumed that the density of the particles remains unchanged, and the particle size gradually decreases as the mass decreases. Through the thermogravimetric experiment, the relationship between the particle diameter and the mass lost is fitted. And the next section is the simulation condition. The object simulated is a vertical falling reactor, and the model is shown in Figure 3. The gas and the sewage sludge particles both flow from the top to the bottom, and the parameters used in this simulation are listed in Table 1. And then the model verification to verify the CFD-DEM model. The results calculated by the model are compared with the experimental results. Figure 4 gives a schematic diagram of bubble bed geometry, and the Figure 5 shows the comparison of average particle temperature evolution, and is comparison with experimental data. The simulation data shows good agreement with the experimental data. And in the figure on the left illustrates particle phase temperature distribution. The particle phase, once particle fall into the reactor, the temperature of the particle rises sharply, and then slowly, and the temperature of the particles existing the reactor is relatively uniform. The figure in the middle gives gas phase temperature distribution. After the gas enters the reactor, cools down sharply, and then at the same time it is heated up by the wall temperature, forming a temperature distribution with high boundary temperature and a low center temperature. The figure on the right demonstrates the pressure change from entering to exiting the reactor. The pressure drop is more than 1,000 pascal per meter, indicating that this type of reactor has a relatively high resistance and should not be designed too long. And figure 7 shows the flow region of particles in the reactor at a different time. At the initial stage, the flow region is nearly horizontal push flow. Under the action of gravity, the velocity difference between the particles near the wall and the particles at the center become bigger and bigger. So the flow region changes to a convergent flow. In section 4.3, the influence of different heat transfer methods are discussed. The two types of particles, the temperature of the two types of particles both increase greatly in the initial time, but for the particle near the wall, the temperature quickly regresses to stability. However, for the particle near the center, there is still a rise in the late period. The reason is that after the flue gas heated the particle, it cools down, and then it is heated up by the wall as described in former sections. And for the two types of particles, the conduction heat flow, you can see the black line dominated the heat transfer process. And the evolution of particle temperature at different inlet temperatures is shown in figure 9. As the inlet temperature goes up, the temperatures of particles rises quickly, and so does the outlet temperature. Due to the increase in the temperature differences, the gas inlet temperature has a great influence on the heat transfer. And the evolution of particle temperature at different wall temperatures is shown in figure 10. As we can see, in the initial time, the temperature rise speed are almost the same under different conditions. This is because in the initial time, the temperature difference between the flue gas and the particle are huge. The convection dominates the heat transfer, and as the particles goes down, the influence of the wall temperature begin to appear. The reason is similar as that in figure 8. And the left figure examines the particle size effect on the heat transfer. It can be seen that the smaller the particle size, the faster the temperature the temperature rises. The reason lies in that with smaller particle size, the bed porosity and the gas velocity will increase accordingly, which will enhance the heat transfer. Besides the contact area of total particles will benefit. But as a whole, the particle size effect on the heat transfer is not so obvious. The right figure shows the particle variation effect on the heat transfer compared to a constant particle size. The temperature rises more sharply when we consider the particles change. So the next section is the conclusion. The applicability of the CFD-DEM model and the heat transfer submodel to the flow and heat of sludge particles in a vertical falling reactor are verified. The main conclusions are as follows. The temperature of the particles flowing out of the reactor is relatively uniform, and the pressure drop of the fluid is relatively high, which is 1,329 Pascal per meter. Convection heat dominates the process of the heating particles, but the temperature of the wall also affects the convective heat transfer to a certain extent. The temperature and flow rate of the inlet gas has a greater impact on the heat transfer, followed by the wall temperature, and the particle size has less impact. That's all. Thank you for your listening.
Okay, thank you, Dr. Ge. So, any question to him? No question? It's a very complicated model, yeah. So if no question, we will move to next speaker. Sorry, I don't have the introduction, the resume, the CV of the sixth speaker.
Hey, am I the new
I'm
speaker?
wondering whether the sixth speaker is here.
Am I the next speaker? Hello.
Okay, I'm sorry.
Hello.
So could you please introduce yourself? Because I don't have your CV.
I'm sorry. My name is Hacer Ak. I am an alumni of Yıldız Technical University of Istanbul.
Sorry. I just closed my speaker. Could you please introduce yourself because I don't have your CV.
Sure. My name is Hacer Ak. I am an alumni of Yıldız Technical University, and I work for. I have a PhD from Stevens Institute of Technology in Sustainable Environmental Management. I am now working as an environmental engineer for Sludge. I am trying to fix this. sorry. I'm so sorry. I think this will be easier. I have no idea if I am able to share my screen with you.
Yeah, please.
No?
Yeah, I can see your screen, but very small.
Better now?
The same. Not full screen.
Not full screen. I see it as a full screen. I don't know. It says your screen is paused.
You have to enable the editing, the yellow one.
Is it better now?
Hacer, oradaki sarı çubuğa basıp enable the editing yapman lazım.
Yaptım.
Biz göremiyoruz ama.
Yeah, enable editing. Yeah, maybe helpful.
Stop share görüyorum ben. Recording the video cloud. Your screen share.
Protected views gelmiyor mu sana? Protected view.
Yo, ben direkt şey görüyorum.
Bizde bir sarı
Full
şey var.
screen görüyorum. New share desem. Tekrar denesem.
Tekrar yükle bakalım. Ha, ona bassana. Tamam. Oldu.
Oldu mu?
Ama şeye bas. Full ekrana bas. Şu yüzde oraya.
Ben kendimi de görmüyorum da şimdi oldu mu?
Oldu. Biz sizi görüyoruz. Kolay gelsin.
Oh, sorry about the delay. Thank you. Teşekkür ederim. So I am an environmental engineer from Sludge, and I would like to thank my colleagues, especially Tolgan Sarac and the industrial waste manager of our company, Bekir Tombul. Without their contributions, this work couldn't have been possible. So I will be talking about the RDF production potential of Turkey, mostly in Istanbul. The content, I will be talking about giving basic information on RDF. I will be talking a little bit about the legal framework regarding the RDF in Turkey, followed by the introduction of RDF in the cement industry as a secondary fuel. I will be mentioning about the current waste management in Istanbul and give details on our RDF plant and the analysis that have been conducted and the results of our study. So here you can see the RDF plant, which is located in Kemerburgaz, Istanbul. It looks much better in person, so if you haven't visited it, you are more than welcome after this pandemic is over. So the process flow chart of our RDF plant, the waste is brought to the primary shredder, where the waste is shredded into 8 centimeter pieces. The waste is then fed to the magnetic separator, where the ferrous metals are recovered. And then the waste is fed to the eddy current for the non-ferrous metals to be recovered, followed by the ballistic separator for the plastics. Then the waste is fed to the fine pressure, where the waste is crushed into 3.5 centimeter pieces. And then the waste goes to the bale press, and the bales are formed and sent to the cement facilities to be used as a secondary fuel. RDF is a secondary fuel in the cement industry. Turkey is one of the world's top 10 cement producers, with 85 active integrated cement factories. Normally, cement facilities require fuel to meet the energy for their production. They operate at 1450 Celsius. I'm sorry, 1450 degrees Celsius. Thus, the use of fossil fuels to operate is high, like so high. According to the literature, at least 65% of this fuel can be compensated through alternative fuels. When the legal framework on the use of RDF as a secondary fuel in Turkey is investigated, it can be noticed that the production of RDF did not have a regulation until 2010. The first legislation was published on 2010, where the principles regarding the disposal of wastes on incineration plants and their use as additional fuel in the industrial plants are regulated. Another regulation was published on the official newspaper in 2014. And the last directive was in 2017, which makes it mandatory for facilities that have a higher than 5,000 tons per year waste feed. They are mandatory to use RDF now in Turkey. Here we see the distribution of cement plants in Turkey. This is from the Turkish Cement Manufacturers Association's data. You can see there are 55 active integrated facilities and cement plants and grinding units. They are distributed all over the country, Turkey, and you can see a lot of them are located in the Marmara region around Istanbul. To produce 1 ton of cement, the equivalent of 60 to 130 kilograms of fuel and 110 kilowatt hours of electricity is required. So you can imagine to run these many facilities, how many tons of fossil fuels will be needed. According to the Turkish Cement Manufacturers Association's data, 35 of the 55 facilities have licenses to use waste as a secondary fuel. In this figure, you can see the use of alternative fuels was only 47 tons in 2007. It almost doubled in 2008, like 88,000 tons were used. And only in the span of a decade, it has exceeded 1 million tons, which shows us the demand is getting higher. And this only corresponds to 7% of the thermal substitution rate. In order to participate in the circular economy and also to reduce the cost of fossil fuel consumption, the technique of co-processing had been employed to introduce alternative fuels as part of the manufacturing process. Lower cost of production, as well as reduction of environmental liabilities, less carbon footprint, less landfill requirement are achieved by using alternative fuels in the cement industry. I will be talking about the current solid waste management in Istanbul. Sludge is responsible for managing the waste of Istanbul. 7 million tons of waste is processed yearly. 16,500 tons of waste per day is landfilled in the sanitary landfills that are located on both sides of Istanbul. 1,200 tons of packaging waste is collected separately at source, and 2,000 tons of waste is composed or bio-dried daily. The composition of the municipal solid waste is good enough to produce the required RDF, but we operate our RDF plant with non-hazardous industrial and commercial waste. 105 153,000 tons of industrial waste that is generated mostly in the Marmara region is treated in the industrial waste facilities annually in Istanbul. We treat 80 tons of non-hazardous industrial and commercial waste to produce RDF in our facilities. Here we can see the clinker and cement capacities of Turkey as of 2019, according to the data of Turkish Cement Manufacturers Association. It is seen that the total capacity is 144 million tons of cement is produced yearly. And most of the production is around in the Mediterranean region, followed by the Marmara region, with a clinker capacity of 20.5 million tons and cement capacity of almost 30 million tons. Here we see the standard limit values for the chemical analysis of RDF are summarized in the table. Moisture content, calorific value, chlorine, and sulfur content are the most important parameters. Higher chlorine contents weakens the 2, 7, and 28 days compressive strength of concrete, thus weakens the cement. Nitrogen and sulfur have a lower value in RDF compared to fossil fuels, thus the formation of nitrogen and sulfur oxides decreases by the use of RDF in the cement plants. The moisture content and the calorific value are essential, are important, as they will be fed to the cement kilns where the temperatures are as high as 1,450 degrees Celsius. The materials that have been sent for this particular study to the laboratory analysis in our RDF plant are shown in these pictures. As you can see, rubber, paper, textile, and plastics were the input to the facility. We also generated 2 different mixtures to investigate the optimum RDF combination. The raw rubber, paper, textile, and plastic, and 2 batches were sent to the facility for analysis. 10% rubber, 50% textile, 30% paper, and 10% plastics were combined for the first batch, and 40% plastics, 10% paper, 10% textile, and 40% rubber were mixed for the second batch. Here we can see the chemical analysis summarized in the table. Moisture content, calorific value, chlorine, chlorine content, ignition loss, density, pH, higher and lower calorific values, total sulfur content, and ash content of each material and each mixture have been analyzed. As you can see, even though the mixture of the raw materials is below 4.6, that of the mixtures are higher, which gives us the prediction that either the batches were exposed to rain or some other source of water before taken to the laboratory, which is highly undesirable, as the water content might affect other parameters as well. So the results of the study: the Marmara region of Turkey is one of the top producers of cement and clinker. It is essential to increase the amount of RDF that can be used as a secondary fuel at the cement facilities and clinkers. Istanbul has the potential to increase the daily production of 1,200 tons of day, and Sludge is planning to increase its RDF production capacity from 80 tons a day to 500 tons a day. Lessening the fossil fuel consumption of cement facilities and clinkers will lead to preserve the national financial resources, thus to achieve a more circular economy. It is important to keep the dryness of the materials to be brought to the RDF plant, our results. Thank you very much for listening, and thank you again, my colleagues, Tolga Hansarac and especially Bekir Tombul for their contributions. Any questions?
Thank you for your presentation. I'm wondering, do you have any standards for your RDF products?
Yes, we do. Input standards or output standards? I have shown here. Humidity should be below 20%. Sulfur content should be 0.5%. Chlorine content should be less than 1%. And ash content should be in between 8 to 12%.
So this is the standard for RDF product?
Yes.
Okay. Only one kind of products. For example, I remember in USA, their RDF can be divided into 7 grades. Then the quality can be different. So
yes,
for your RDF product, yeah, you did the same.
We also have different qualities, different types of qualities that we can produce. But as we are sending our RDF to the cement facilities, they require high quality RDF. So we are not feeding the facility with municipal solid waste. We are feeding by industrial, commercial, non-hazardous waste. So to produce only high quality RDF. Normally we can produce low quality, middle quality, and high quality RDF.
Okay, thank you.
This study is for the high quality RDF production.
Okay, so I'm wondering the price range. For example, what's the price for the high quality RDF, and what's the price for the low quality RDF?
I had them somewhere. Can I send you the information later?
Yeah, I mean the price. You mean
there's
you
a
have
range.
different? Yeah,
There's a huge range. The high quality is a little bit expensive, a little bit higher than the others. It depends between like up to 80, 100 Turkish liras per ton, I can say.
Okay, I see. Ni have a question. Yeah, please. Yeah, please ask your question.
Already written down. But I would like to ask, do we have enough diversion rate for municipal solid waste for Istanbul? It would be better if we collect our municipal solid waste separately. We should have done maybe already. Do you understand what I'm asking?
You're asking if it is better to collect wastes from source separately?
Yes.
That is the ideal.
We should.
Perfect. Yes, that would be perfect if the enforcements were more strict.
I think we are a little bit late for this. We should have done. We have already done this kind of separation long time ago, maybe.
Yes.
Okay,
yes.
just the remembrance. I just wanted the remembrance to İstaç. Be hurry up.
Yes, I see. We should hurry up. Okay.
Thank you.
The next speaker is The next speaker is Yannick. No, sorry, it's Northern Servant Topso. I'm sorry, it's difficult for me the name. So I wonder the speaker is here, and could you share your screen?
Yes, I can have it.
Yeah.
But can you unshare the screen, Hajar, dear Hajar?
Yeah, the former speaker should close your screen. Otherwise,
Can you see my screen?
now the former speaker, please close your screen. Yes.
Can you see?
Yes. Yeah. So because it's difficult for me to pronounce your name, so Northern Servant
Yeah.
Topic, could you please just give a very short introduction of yourself?
Okay. First of all, hello everyone. I am Nurdan Sevde, and I'm studying as a master's student at Ege University. And also, I finished my bachelor degree in this at same university. So, my presentation about valorization of phosphorus. My speech includes importance of phosphorus, objectives, materials and methods, results, and for the last conclusion. So I would like to start with what are fertilizers. As we all know, the chemical substance supplied to the crops to increase their productivity. It contains the essential nutrients required by plants, including nitrogen, potassium, and phosphorus. So there are 6 types of fertilizer, which are farm, barnyard, green, and commercial fertilizers. And commercial fertilizers also can be classified as nitrogenous manure, phosphatic fertilizer, potash fertilizer, and compound. So if you look at the application of phosphorus, and most of using phosphorus as fertilizer, as I mentioned before, also we can see the phosphorus as nutrient, water softener and brightener for some metals. Also, and lastly, we can find the phosphorus in non-alcoholic beverages. And it is known for its effect in capturing the sun's energy and converting it into a beneficial plant compound. The research you can find that they say that the phosphorus is directly related with the development of plant. And the lack of phosphorus, we can observe the discoloration, like in this picture. So when we come to the problem related to the phosphorus, it is limited and non-renewable. Phosphate drugs are raw material for phosphorus fertilizer. It is clear that these drugs are being exhausted. Besides being a limited source, extraction of phosphor from these drugs also create dangerous waste. And removing the impurities requires high energy. So I told you that the phosphor is the main one of the main nutrients of our plants. So and it cannot be replaced with the other elements. So that is why the phosphate drugs appear in the critical materials list of European Commission. So it is important to recovery from waste from the point of view economical, sustainability, and environmental aspects. So there are some biomass such as olive, sludge, meat, and bone meal, and also poultry litter contains a considerable amount of phosphorus. And why we use the poultry litter as a phosphorus source? As seen from the table, in Turkey, due to the intensive farming, poultry litter raise serious concern about treatment and disposal. It is traditionally used as fertilizers, such as fertilizers, but the potential environmental problems, such as spread of pathogens, emission of greenhouse gases, and odorous compounds, are reported due to their overuse. Existing technologies such as combustion, anaerobic digestion, gasification, pyrolysis, and hydrothermal conversion may be an alternative way for proper management for these wastes. Our main purpose is to recover phosphorus from pulp litter to be used as mineral fertilizer, and to investigate the total and bioavailable phosphor content in the pulp litter ash from a power plant. And in our study, we carried out thermochemical processes, which are hydrothermal carbonization and pyrolysis. In this process, the effect of these experimental conditions on total phosphorus and bioavailable one. So the pulp litter supplied by Grass Company, the first air dried and oven dried at 150 degrees, and pulp litter ash also supplied by Grass Company. In here, main inorganics in pulp litter and pulp litter ash. As seen, the pulp litter ash has considerable amount of phosphor. The huge amount of calcium in both is due to the animal's diet. Here you can see the general scheme of experiment. We use pulp litter derivatives. First, ash from combustion plant. Some research are suggested that can be also used as fertilizer. The second one is biochar and the hydrochar. On the other hand, biochar is produced from pyrolysis, and hydrochar is produced from wet pyrolysis of pulp litter. So these char have agronomic value, and they can be used as soil amendment, as well as the solid biofuel and other applications. So because of this, in our study, we determined the phosphorus contents and types in chars. I would like to start with the hydrothermal carbonization. It is environmentally friendly and inexpensive process of wet biomass under autogenic pressure and low temperature. This process is also preferred because of its high conversion efficiency, availability of biomass without pre-drying. After hydrothermal carbonization, we have three products, which are gas, liquid, and solid one, which is named hydrochar. We carried out our experiment stainless steel autoclave at 3 different temperatures and 2 different reaction times. In biochar production experiment, dried poultry litter pyrolyzed under nitrogen stream at 3 different temperatures for 1 hour in lab scale in vertical fixed bed reactor. During pyrolysis, volatile products passes through the traps where the liquid are collected, and non-condensable volatiles released to the atmosphere. I'm not sure if you can see the trap in here. And also we have 3 products after pyrolysis, gas, liquid, and solids. Also the solid names as biochar. So in speak of analysis, we determined the total phosphorus by ICP, and available phosphorus determined by Olsen method, and inorganic contents determined by XRF. For the surface morphology, we made analysis of XRD, SAM, EDAs. So when we come to results, here we have the yields of chars. As expected, with an increasing temperature, the biochar yields are decreased. The reason of this, the biomass decomposes in high temperature according to the low temperature. So we can say the same thing in biochars, but there is still no significant changes. Now I would like to talk about the fuel properties of biochars and hydrochars. So if we compare the amount of carbon in biochars, biochar 300 has the highest amount of carbon. The reason is the ash content is the lowest one. So if we want to use as biofuel, we must choose the 300 biochar. So when we look at the hydrochars, the hydrochar 260 minutes has the highest ash. These two are really close, but if you look at the ash content of them, so this one is the lowest. So if you want to use as a biofuel, we are going to choose hydrochar 260 degrees. And also we compare the total phosphor, calcium, and soil available content of pollinator ash in chars. So I would like to explain the soil available in a short. It defines the phosphor that can be easily taken by plants, and it is more important than the total amount of phosphorus. So as seen, pollinator ash has the highest phosphorus content, but it has the lowest. It has the lowest available phosphor. When we compare the total phosphor amount of biochars here, it is clearly seen that during the pyrolysis, phosphor remains mostly in biochars. Available phosphor decreased above 400 degrees, probably due to the formation of insoluble phosphate salts like calcium phosphate. In hydrochar carbonization, also hydrochars considerable amount of total phosphorus, and the total phosphorus amount increase with increasing temperature, but duration time above 220, phosphor content decreased by the duration. On the other hand, the duration, the time here, the duration time soil available phosphorus decrease by the temperature. Duration time soil available phosphorus decrease compared to the temperature. Okay. So here you can see the distribution of phosphor and calcium on chart. In hydrothermal carbonization, in general, a process, most of inorganics in biomass goes to the processed water. However, in our case, the most of phosphorus and calcium in poultry remain on the char instead of processed water. As seen from the table, between 80 and 100% phosphor remains on the hydrochar. On the other hand, most of calcium in poultry litter, 50% of also remains on hydrochar. So here we have the pollinator ash and the XRD analysis. We can see the compounds of calcium oxide with a plus in here, and or in a form of complex phase calcium phosphate silicate. We also make the XRD analysis, the selected biochar and hydrochar. When we examine their analysis, we can see the calcium carbonate crystal. So there is no phosphorus crystalline in structure. So in conclusion, the hydrothermal carbonization yielded a higher energy densification than pyrolysis, but both processes produced the high having a low calorific value comparing to the biomasses due to their high ash content. On the other hand, results show that the large amount of phosphorus feedstock was retained in the biochars and hydrochars. So it was concluded that the biochars and hydrochars derived from pollinator can be used as soil amendment rich in phosphorus. So, and also this project has been supported by European Union Airmen 2 and the TÜBİTAK. I would like to thank for them. And here are my references, and thank you for listening to me, and sorry for being fast because I don't think that we have much time. If you have any questions, I can take
thank
it.
You. Thank you for your presentation. I see a question for you already.
Yes.
Yes, a question for you in the chat. In chat area. Yeah, chat area. I see.
Okay.
Yeah.
I cannot open.
Yeah, but I see. Yeah, I think the ask the question can speak a lot.
Okay. Why the increase of duration time reduces phosphor ability? Okay, with an increasing time, I think the chars, the phosphor remains on the chars. That's why the decrease of phosphate. Okay, wait. Why the increased duration time reduces phosphor ability? I think because the phosphorus remains on the hydrochar. That is why. For the young Feng, the answer is Gözütüman increase in solubility. Okay, they already say it. Okay.
Okay. So do you recommend is hydrochar or just char from pyrolysis is better?
Sorry, can I take
Which one is better? Is hydrochar or biochar for first phase utilization?
For soil available one?
Yeah. I mean, which one is better?
Okay, we can take it. We can look at this here again. So the biochar will be better for the soil available.
Okay. So, any other question? If no question, we will close this section. Thank you all for your attendance and thank you all for your patience. Thank you.
We thank Desin Chen, all participants for their participation. We can see you at 1 o'clock in session 5. Thanks for your attention.
Thank you.